So in this case, we are going to consider our second moment of area, which is actually the introduction. So basically, we had the introductions and calculations, remember, from your N5 mathematics. So we dealt with the basics before. So I'm just going to add one or two that we need in our calculations, right? So remember from your N5 mathematics, all right, if you are to consider back from our N5 mathematics, we dealt with the second moment of area, which was basically on the rectangular. It was calculations on the rectangular and the circular laminas, remember? So when we dealt with the second moment of area there, you calculated, all right, the second moment of area of the strip, considering the strip. And you say this is going to be the distance, all right, squared, which is the distance from the reference axis, all right, the distance from the reference axis. You square that distance, all right, then you multiply to the area of the what? The strip, which is the strip area or area of strip. Remember that. This is what we had from those laminas. And now we are going to use the same concept of our calculation of the second moment of area as based from our N5, from what we had before. But this time in our N6, we are now considering that second moment of area being calculated where you are given a curve or two curves, depending with the question. So now our second moment of area is based, all right, is based on the calculation of an area. So it's going to be based on calculations, all right, of an area that can be enclosed between, all right, it can be enclosed between a given what? Between a given curve. So we can have that curve and an axis, all right? So now we are considering these calculations on a curve, all right, where we can have, all right, in this case, we're gonna consider something like this, all right? So let's say this is the curve, between the curve and the x-axis, or it can be between the y-axis. So that is the consideration. Or we can actually have these, all right, like this, or we can actually have something like this where there are actually two curves that we are having. So it's something between, all right? So that is what you can have. So this can also be referred to what? To a condition where it is what? Between, where it is between two given curves. So that is our consideration this time when we are to calculate the second moment of area. So like what we had before, the calculations still the same. So meaning to say, for us to obtain the second moment of the area from what we had, you were going to what? To integrate and take the limits from A to B, depending with the axis that you are using. So here I'm just going to use A and B. Then we're going to have R squared representing the distance from what? The reference axis. Then the strip area, that is our dA. So that is the formula, guys, that we are simply going to apply. Only that is considered now from the graphs. You have a graph that you are supposed to draw, a curve that you're supposed to sketch. Then from that sketch, consider the area expression Remember your area expressions from our curves, and the R there being what? The distance from the reference axis from what you be given. So we are going to consider those calculations, but as we are considering, I would just want you to see something, just one or two here, so that we'll be together. I'm just going to put the calculations later on, and also to just prove one or two calculations, but the best that we're going to just do is to have our calculations, I mean, the formulas, then I think that is best because it's just a repetition. But just for the sake of revision, I'm just going to also update where actually this is being taken from. So let's consider something like a curve and the x-axis, all right, where we're going to consider a curve where you're given a curve and the x-axis and the x-axis like this. So there are some properties that I need to explain before we consider the formulas. So let's say we are given a curve and it's bounded between the what? Between the x-axis. It's found something like this or curve like this. So meaning to say, this is the part that we are focusing on, which is bounded between the curve and the what? The x-axis. So what you are going to simply require or to need are the what? Intercepts with the what? With the x-axis, which in this case, we're just going to call them A and what? And B. So having these intercepts, A and B, when you're given a single curve, this is a single curve. So remember what you deal with. These limits, which are the what? X-intercepts, will be the limits that you use. Remember the limits when I'm talking about integration. So those are the limits A to B that you're going to apply. So these limits are for what? X. So definitely what is important is to have what? The representative strip for X. Remember that. So you're going to have the representative strip for X. So as of the second moment of area that we are dealing with, there is the strip area with respect to x, with respect to x. So meaning to say, if we are given this function, it is supposed to be y is equal to what? F of x, where the strip area, in this case, if you are to consider the dA, it is simply from y dx. The given function times what? Times dx. Remember your area strip, guys. When you calculated area, then you integrate this to obtain what? To obtain the area, where area is the integral of what? Y dx. Remember that? So here we are talking about what? The dA, the strip area, representative strip that you're given. So we can have this area in that manner. So it's very important to consider those basics that you had before. All right. My focus is not about this one. My focus is about what we are going to calculate from here. I'm using this as just an example. There can be between a curve, you can have a curve and the y-axis, all right? It can be actually bounded between the two curves. We're going to look into that. But for basic illustration, let us work with this one. So from here, there are two things that we are supposed to take note, which are the solutions to the given graph, which you're going to use as the limits of the integral AB and the strip that you are working with, as this is going to affect our calculations for the what? Second moment of area. So the second moment of area, when you are to consider the calculation, it can be taken with respect to x. It can be taken with respect to y. So I want us to consider from that diagram and from the calculations that can be made. So this is not about the the strip here, this one. It's not about the strip, this one here. This is the representative strip there. It's not about here, this one. This is with respect to the axis, which is the reference axis. This is what with the respect to the reference axis. The reference what? Axis. So we are referring to the x-axis and this one to the y-axis. So what happens is that when you are to calculate that second moment of area with respect to x, you must consider the representative strip there, what you are given on the strip. Is the strip that you are given parallel to the reference axis? When I talk about now together, is the one that you're calculating there. Is it parallel or is it perpendicular? So if we are to consider this part here that we are given, if we are calculating the second moment of area with respect to x, it means our reference axis is what? Is the x-axis, where the x-axis and the representative strip, they are what? Perpendicular. They meet at what? At 90 degrees. So this one is perpendicular to the representative what? The representative strip from our diagram. I'm talking about this diagram that we're having here. I just want you to see some other things that you're going to refer later on because they'll be taken from these. Then you'll be wondering, what is it that we're explaining? All right. So if you were to consider calculating the second moment of error with respect to y, where the reference axis is y this time. So it's not about the strip, no. It's about what you're calculating with respect to what? It's with respect to y. But the strip that is given is for x. So you consider to say, this is my reference axis, this time yx with respect to y. So this is my reference axis. And this is the representative strip. What is the relationship between these two? What you are calculating and what you are having on the diagram in terms of the strip. What is the relationship? Are they parallel or perpendicular? These two, they are parallel. The y-axis, the strip is like this. So these two, they will never meet. They are what? Parallel to each other. So in this case, it is parallel to what? To delta x, which is our strip. So why am I referring these? The relationship between the reference axis and the strip. It follows that, all right? So here, let us just have the relationship between what? You understand me very soon. You understand me very soon. The relationship between the strip, the representative strip, between the strip and the reference axis and the what? The reference axis. So this here affects the distance r. This relationship, it's gonna affect what? Our distance r. If we are given a condition where the strip is parallel to the reference axis, all right? So the first condition, it can be when the strip, all right? When the strip is what? Parallel. And the strip is parallel to the what? To the reference axis. To the reference axis. We want to see that from the diagram, from this example, where it is parallel, like y from the x, delta x, the strip y, and this y-axis and this, they are what? They are parallel to each other. So when that condition happens, our r is taken as equal to x. Equal to x. The r now is the what? Distance perpendicular This is the distance from the reference axis, the distance from the reference axis. So that one is going to be considered as what? As x. All right. So meaning to say to the opposite one, which we are going to use if it was for the y-axis, you're going to consider whatever that you're calculating for x, r is equal to y. So in this case, r will be equal to x when you are given that condition. So when the strip is parallel to the reference axis, our r can be equated to x, or r is equal to y, depending with what you are working with. So in this case, for this one that we are having here, because of the curve between the x-axis. So our r is equal to what? Our r is equal to x. We are going to look into another one where we are going to have the curve and the y-axis. That's when you're going to see that r will be equal to y, and there it will be the second moment of area with respect to x that you're calculating. So that is what you have to consider. So here r can be equal to x, r can be equal to y. So that is the most important thing. So here definitely you'll be calculating what? The second moment of area with respect to the y. This one you'll be calculating the second moment of area with respect to x. So you take your r being equal to that distance direct as it is, all right? Then the second one, they can be perpendicular like what we saw here. We can have this condition where you're calculating the second moment of area, the reference axis and the strip, they are perpendicular, all right? So when that happens, all right, when another condition, when the strip, all right, so you're going to consider when the strip is what? Perpendicular. When it is perpendicular to the what? To the reference axis. So here, just for revision purposes, but if you can understand the formulas, I'm gonna give you the formulas, all of them, for those who are good at memorizing the formulas. This won't be important because those formulas, they are straightforward for every question that you're going to be given in exam. So, but this is where it was taken from, just for you to understand, all right? So when the strip is perpendicular to the reference axis, your r will be equal to x over the square root of 3. And your r can also be equal to y over the square root of 3. So in this case, we are going to square it, all right, since we have got r squared, so that we do not have these square roots, guys, in confusion. So if we square that and square this, it's going to be x squared over square root of 3 squared is what? 3. This one is going to be y squared, this one 3 squared. So here, guys, I want you to take this one as it is. For us to explain where it was taken from, this one is going to take us a lot of explanation, but for now, I just want to take you, I want you to take I want you to take this part as it is, all right? So r squared will be what? X squared over 3. And, all right, or that another one can be of what? Of r squared in terms of y. So it's going to be y squared over what? Over 3. So this part, guys, I just want you to take this part here as it is, this part, all right? Just like here as it is. So that is it's gonna be actually difficult for us to figure out where this was taken from. It's gonna be a lot. For x, it was just direct. You can see that is the distance, right? So, but for any consideration of the second moment, that is how you take that, right? So your r is from what? X, which is over the square root of 3, but you have to square that since it is r squared, all right? So that is the condition. So remember, guys, when x is given, it means the second moment of area that you're calculating is for y there. When y is given, it means your second moment of area that you're calculating is for what? Is for x. So this part here is the one that we are going to use in formulating the formulas, all right? Which, guys, I said we can consider just having the formulas just like here, guys. If you can memorize this, it means you can also memorize those formulas. But anyways, let me show you where it is being taken from. So using this condition, this one, let's put it into consideration from this part. So I'm working with this one. I want us to see from this one. So there we have got a curve and the x-axis, all right? So let's say the question was asking you to calculate the second moment of area with respect to x. From our formula, the second moment of area formula, this one, all right? You're going to have your formula. I want to see where it was taken from. So you're going to have this Ix with respect to x is equal to what? R squared dA, all right? This is your formula. Where R squared, this part of R, you consider this part from Ix. The reference axis here, our reference axis is what? Is X. So our reference axis is what? Is X. That is the X axis. That's our reference axis. What about the strip? The strip is from our dA. Remember our dA formula, the strip is for X, as you can see also there. So we have the strip for X. So you check the X axis, the reference axis, and what? And the strip. How are they related? They are perpendicular to each other. So if they are perpendicular to each other, it means how do we take our R? If they are perpendicular, we go back to these two. So where they are perpendicular, R squared can be related to this part that you are dealing with. So in our case, since we are calculating the second moment of area with respect to x, it means our R squared is equal to y squared over what? Over 3. So our R squared here is equal to y squared over 3. We saw, guys, where this was taken from that square. So I want you to formulate the formula here. So you're going to take that, all right, A, B, your R squared. What is your R squared? Y squared over what? Y squared over 3 times the dA for the strip. For the strip, it's what? It's y dx. So that is where those formulas are being taken from. So here's over 1. So you can take the 1 over 3 outside. So it will be the integral of what? Y squared times y. That's what? Y cubed with respect to x from A to B. So that's our second moment of area with respect to x. That's how you simply play around with these formulas. You can formulate the formulas. So when you are given this, that is how you can simply play around. So that's our Ix, this one. Ix and dx, they are perpendicular. These two, they are perpendicular. So it affects our R. But if it is Iy that you're calculating with respect to y, so you check the strip is for what? For x. So these two, the y-axis and the strip, they are what? Parallel to each other. So this case, we are talking about what? Being parallel. So if they are parallel, what's the relationship? R is equal to x or R is equal to y. So since we are calculating for y, so R is equal to what? X. We are calculating the second moment of area with respect to y. So Iy, it means our R is equal to what? Our R is equal to X direct as it is. So meaning to say from that formula, the second moment of area with respect to Y was going to be what? R squared. Our R is what? X. So that's X squared times the dA, which is the area expression, Y dx. From A to what? B, the limits of our strip. So this is the formula that you're going to have at the end as the second moment of area with respect to what? With respect to y, this one. So we can formulate these formulas, guys. We can formulate these formulas and so on, so on. All of them. So what I want you to take note is what you are dealing with in terms of what? In terms of the calculations. Here, it is about what? the reference axis to the what? To the strip. They are what? Parallel, as we saw. So that will be r squared, where r is equal to x. So that's x squared from r squared dA. So that's how you play around with this. All right? So let us try to formulate using the same concept. Let's say, so these are the ones that we can expect when we've got a curve and what? The x-axis. So let's have the curve and the y-axis just for revision purpose, right? Let's have another one. The curve. So we're going to consider where we are given a curve and what? And the y-axis. So all this is between, is the area between, all this is area between a curve and so on. So it will be the second moment of area of that. So if you are given between the curve and the y-axis, you're going to say have something like this. All right. So let's say this is the condition. So this is taken from C to what? From C to D. So whenever I'm using the limits for the y, I'm just going to use C and D so that we understand the difference between A and B. A and B, we're going to use them for what? For X. So let's say we've got this. That will be our representative strip for y as we are given. So meaning to say, with this, to calculate the second moment of area with respect to x, all right? Let's start with x. So you consider what is affecting our x. The strip is for y, all right? So how is it related? The x-axis and this strip like this, how are they related, guys? They are parallel to each other. They will never meet. So these two, they are what? Parallel to each other. So if they are parallel to each other, how does it affect? It affects our r. R is equal to x or r is equal to y. So we are dealing with x. We are dealing with respect to x. So r is equal to what? R is equal to y. That's how you simply play around with that. So r will be equal to y. Then remember your formula. Ix is equal to the integral of what? R squared dA. So in this case, our dA will change because we are dealing with these limits for y. So the curve must be taken as y in terms of f of x. So this one is going to be x in terms of f of y. So x is equal to what? F of y in this case. All right. So the curve has to be written in that manner where x is equal to what? Where x is equal to f of y. And the area of the strip can be calculated from what? X. So it will be x d, all right. So x dy here. All right. So that is what we gonna have, all right, dA. Guys, what am I writing here? dA, the area, all right? So that's x dy, x dy. So that's it. We're going to integrate that with respect to y, yes. So that is what you have for the strip, the dA. So in this case, if you're going to use that formula, r squared, our r, because of what? Ix is y. Remember parallel. So we said r is equal to what? Y. So it was going to be y squared times what? The dA, which is xd, which is xdy. So that's it. From C to what? From C to D. So that is what you were going to have as the formula representing what? Ix. Since r is equal to what? Since r is equal to y. And we move on to the second moment of area with respect to y. So when it is respect to y, you consider y, which is our reference axis, and the representative strip, they are what? Perpendicular. They meet at 90 degrees. So you refer it to what? To the representative strip. These two, they are what? Perpendicular. So if they are perpendicular, r is given as what? All right, for perpendicular, r squared is x squared over 3 or y squared over 3. So we consider that. So here, with respect to y, so r squared is equal to what? X squared over 3. Is these two, remember, the opposite. You take it in terms of what? X. So that's it. So meaning to say, going back to our formula, it was going to be the integral of what? R squared. our r squared. Our r squared is what? X squared over 3 times what? The dA formula, which is what? X dy, like that. So simply going to take 1 over 3 out of the integral, all right? So that's 1 over 3, the integral of what? X squared times x. That's what? X cubed with respect to y. So this is the formula that you're going to use. So that is every time we are given to calculate the second moment of area, where the what? Where the representative strip is for the y, these are the two formulas that you're going to expect to use, all right, depending with what you're given. So you just consider, guys, how are they related? So you saw that the first one, this one, ix and dy, these two, they are what? They are parallel, all right? They are parallel, and these two, they are what? They are perpendicular, just like that. So you use these guys anyhow, just like what we saw here. So these will be what? The two formulas that we'll end up using at the end. Between a curve and what? The curve and the x-axis. This one was what? A curve and what? Y-axis. So it is the same thing, even if there are two curves, guys, that we are given. Even if we are given what? Two curves. Still considering that we can use. Let me just finish up. Let me just finish up for the sake of what? For the sake of revision. Second moment of what? Of area. Right, of, all right, second moment of area of an area between two given what? Between two given curves. Let us just what? Let us just finish up and see where this was actually taken from. So here we can have a condition where the two given curves, remember this time they are now two, an area between two given curves. So we can have a condition where the two given curves are like this, and that's the limits will be for what? For x. The limits taken for x, a, and what? A and b, having the representative strips. Let's say you've drawn your graphs, they're like this, and the representative strip is for what? Is for x. This is what you have. So definitely you're going to have the graph that is on the top and the one that is on the bottom. So you're just going to consider y1 and what? Y2, the difference between these two graphs, remember, from our area concept. From the area concept, so the strip area in this case was going to be the difference y1 minus y2, the top minus what? The bottom. Y1 minus y2 times what? The representative strip that you're given dx. So that was the area of the strip here, remember, from the introduction of your areas. So using this, let us now consider calculating of what? The second moment of area. Okay? So we can have, just like before, guys, we saw that from each strip that you're given, two moments of areas can be calculated with respect to x, with respect to y. So it is the same thing here. We can have these second moment of areas calculated with respect to x and another one with respect to y. But the conditions still remain, the conditions still remain the same. We do not have any effect, no effect. So what was the concept before? Second moment of area, the integral of r squared dA. So that's it. So r squared dA. So the dA, we already have this. What we need is the r. So let's take ix. So for ix, it means we're talking about what? The x-axis. That's our reference axis. The strip that we're given, they are what? They are perpendicular to each other. The x-axis and the strip, they are perpendicular to each other. Whenever they are perpendicular to each other, we go back to the what? to the illustration of our R. All right. We go back to the illustration of our R just like before. Said what will be the condition of our R. All right. So from here, from this one, all right, here. If they are perpendicular, then your R is going to be taken as what? Your R squared actually is going to be taken as X squared over this or Y squared over that. So that was the consideration when you are given this condition. So when we are given to calculate our IX, all right, so we have to consider, in this case, y squared over what? Y squared over 3. So that was the consideration that you're going to have, y squared over what? Over 3. I want us to see something here. So guys, I'm trying like to switch between these two boards automatically here. So this one, from what we had, we're going to consider, all right, it cannot erase, all right, yes. So we're going to consider that this is for x, and we said with respect to x. So what you're going to have in the calculation, it was going to be the integral of what, all right, from a to b. So there, our dA, we have it. But we need what? From the formula y squared over what? Over 3, because it's with respect to x. So it's going to be y squared over 3. So that's our R. Y squared over what? Over 3 times what? The area expression, which is y1 minus y2 with respect to what? With respect to x. So that is the area expression of the strip. So here, since we are dealing with y1 and y2, and that y there is denoting for those y values. So if you are multiplying to y1, you take it as y1. If you are multiplying to y2, you take it as y2. It's just the y of the given graph, all right? So we can take the 1 over 3 out of our integral. Then we remain with what? Y times y, that's to the exponent of 3. So that's y1 to the exponent of 3, y2 to the exponent of 3. Remember, that's a squared. So that is the formula that we are going to have. So like I said, you treat y to the y that you're multiplying. If you're multiplying to y1, you treat it as y1 squared times y1. All right, y2 squared times y2. That y is treated to with respect to what you're multiplying inside. So that is the condition that you are going to have. So this is the formula at the end of the day that you're going to use calculating what the second moment of area with respect to x. So that is these two, they are what? They are perpendicular to each other. So if you're going to calculate for y, the same thing, guys. For y, you're going to check, all right, y, that is y and the strip, they are what? Parallel to each other, all right? So iy and the strip for x, these two, they are what? They are parallel to each other. So when they are parallel, we go back to this concept. R is equal to x, or R is equal to y. So in this case, we are dealing with y. So R is equal to what? R is equal to x. So meaning to say the second moment of area from R squared, R being x, it was going to be x squared. The dA, this is our dA, which is what? y1 minus y2, the dA formula with respect to x. So that is going to be the formula that you're going to use at the end of the day in calculating what? The second moment of area with respect to y when we are given two curves of this nature. And this will be for what? For x. So these two, they are parallel. These two, they are what? Perpendicular. Just like that. This is between the two curves. All right? Same concept, guys. It is going to be the same even if you're given the two curves like this. All right? Even if you were given those two curves considered in this manner. All right? So let's consider this way, okay? So this will be for y this time, all right? Having the representative strip for y, all right? So this is the strip for y, and this is the one on the right, and this is the one on the left. So the one on the left going to be written in terms of x, so it's going to be x1, and this will be our x2. So x, like in terms of f of y, remember guys, um, from those graphs of yours when we dealt with areas and volumes, do the same thing in terms of y, like that. So meaning to say, when you've got a strip for y, I'm going to use the limits as c and what? C and d. So from here, you are going to have the strip area just like what we had on the dA with respect to x. So this time is with respect to y. So the strip area is going to be the difference, the one on the right minus the one on the what? On the left. So that's x1 minus x2 times what? The strip, which is dy like that. So this was going to be the representation of what? The strip area, the one that we are going to use in the formulation of those formulas just like before. All right. So with this, we want to calculate our second moment of area, guys, just like before, knowing that our second moment of area is what? The integral of r squared dA from C to D this time, as we are dealing with what? As we are dealing with these limits C to D. So I'm just going to use C to D, just like what we had here. Let's hope here, guys, we have the same thing here from C to D, just like what we had on this part. All right. So we are going to consider just like before. So let's consider with respect to x. Ix is going to be equal to what? So you consider Ix, that is the reference axis is what? Is the x-axis. The representative strip and the x-axis, they are what to each other? They are parallel. So Ix and what? And the strip of y, these two, they are parallel. So when they are parallel, it affects our r when they are parallel. So r is equal to what? R is equal to y, since you're calculating for x. So r is equal to what? R is equal to y. So it was going to be r squared. That's what? Y squared. R squared, y squared into what? Many times what? dA. Our dA is this one. So it's going to be into this x1 minus x2 dy like that, from C to what? From C to D, just like that. So this is our second moment of area calculation that you're going to use when you're calculating with respect to x, as we saw that these two, they are what? They are parallel to each other. All right, they are parallel to each other. So when you are calculating for y, in this case, same concept. So you are calculating for y, the y-axis is your reference, and the strip, they are perpendicular. They meet at 90 degrees. So these two, they are what? Perpendicular. If they are perpendicular, our r is equal to what? R squared is equal to what? X squared over that. Since you're calculating for y, then it is going to be what? X squared over what? Over 3. So r squared is equal to x squared over what? Over 3. So that is the one that you're going to simply substitute here in place of r squared, x squared over what? X squared over 3 into what? The dA, which is this area expression of the strip x1 minus x2 with respect to y. So our limits from C to D. So that is it. You can take the 1 over 3 out of the integral. So it's going to be 1 over 3, the integral of what? So you multiply the same like before. X there represents what you're multiplying to. So if it is x1, it's x1. If it is x2, it's x2. So x times x, that's what? X squared. So that's x cubed. This is x squared times x. So that's x cubed. So that's x1 cubed minus, you multiply to x2. So that's x2 what? Cubed. So that is the formula that you are going to use at the end of the day whenever you are calculating the second moment of area with respect to y, when you're given two curves with the strip for y like that. So these are the formulas. Like I said, you can just memorize them, all right? So it is in your hands now, guys, as I have introduced. I thought I was just gonna list them down, but as you can see, guys, we ended up having them, all of them from introduction from scratch. Anyways, these are the formulas that you're gonna have, all right? So you choose. Are you gonna just memorize these formulas, all right? A curve and the x-axis, these are the two formulas that you're gonna use, all right? A curve and the y-axis, these are the two formulas, and the second moment of area of an area of an area between two given curves. It can be a curve of this nature. All right. So let us just say consider this as the first condition where we can calculate the second moment of area with respect to x and this one with respect to y, like that. And we can have the second condition between the two given curves like that, but the strip is for y this time. These are the two formulas that you're going to end up using. So that marks up all the formulas that you are going to have as of our syllabus in the calculation of what the second moment of area. Nothing is going to beat up all these formulas, guys. Use them properly. So it is in your hands. Are you going to memorize them, or are you going to take them from this scratch? This is where these all formulas are taken or are to be created from this part, only this part. It is the one that created all these formulas. So it is in your hands. Are you going to memorize all these formulas, or you can memorize where they were taken from? So we're going to look into revisions after this. So make sure you become part of the membership so that you do not miss any of the other classes that you're going to have and revisions. And also, let us communicate, guys. The comment section is there. If there is any section which is not yet complete, because we are targeting to finish all the subsections, all the topics of all the subjects that we started. So it's actually a lot of work that we are working on. So make sure you communicate, all right? The comment section is there where there is a section that is left out, because I might not notice that there is a section that is left, like this one. I thought I actually covered this because I was just having these notes, but I did not even know that I didn't present them here. So guys, let us communicate so that once I have time, I present those notes to you and do revisions where it is necessary. So let's join membership, and do not forget to share our videos to our loved ones so that they also do benefit from the same information that you are using. So for now, that is it, guys. Till we meet again.